Hello everyone and welcome. In this video, we'll walk through the experiment we designed to benchmark vector databases for semantic search accuracy. So what are vector databases? Vector databases store and query high-dimensional vector representations of data, such as text, images, or charts. These vectors capture the semantic meaning of the content, making it possible to perform similarity search. In retrieval augmented generation systems, vector databases help large language model answer queries by retrieving the most relevant chunks of stored documents. Moorcheh is one such vector database, built specifically to power RAG pipelines. It stores documents as dense vector embeddings and returns high-quality, semantically relevant context to support accurate grounded responses from LLMs. To evaluate how well Moorcheh performs compared to other vector stores, we designed a controlled benchmarking experiment. Our focus was on two key metrics: relevance and completeness of the retrieved content. This video will focus on the methodology, how we kept all the pipelines consistent, standardized our documents and queries, used the same chunking strategies, and applied fixed scoring prompts with LLMs like ChatGPT and Gemini to ensure a fair and unbiased comparison. For more information, whether it's accessing the RAG pipelines you built, viewing the full benchmarking report, or exploring the evaluation spreadsheets, feel free to visit the Moorcheh Benchmark GitHub page. We also built RAG pipelines for each of the following vector databases: Moorcheh, Pinecone, ChromaDB, Milvus, QGIS, Redis, Elasticsearch, Mongo Atlas DB, pgvector, and Viviate, as you can see on our screen. We'll be showcasing how to use these pipelines so that you can run your own benchmarking experiments. To begin, let's take a specific look at the Moorcheh RAG pipeline.
So here we have the Moorcheh RAG pipeline, which is copied to a Google Colab for readability purposes. To start, please install all of these packages. And for us, we've installed OpenAI, Moorcheh SDK, LangChain Community, PyPDF, and Pandas. Then we're going to import all of these packages as we'll be using them for the RAG pipeline. Next, be sure to set your OpenAI API key as well as Moorcheh API key in your environment variables. And we'll be using them, to create the OpenAI client, use ChatGPT as the LLM for the RAG pipeline. And we'll also be using our Moorcheh API key to actually create the namespace and upload our documents to it. Next, we set our PDF path, and this is essentially the document that has all of the relevant context that we need to answer our queries. And we have this file shown here, and this is essentially a scholarly article that talks about the rise and recent decline of Tesla shares in the US electric vehicle market. And this is a very informationally dense document. It has a lot of words, and it goes into a lot of detail based on how Tesla's financial outlook kind of is at the moment. And in addition to all the text, it also has many tables and sort of data figures. And essentially, it's just a very informationally dense document, but hopefully we'll be using Moorcheh to sort of make sense of this document and answer some of our queries. Next, we have our queries.csv, and this is the file path for the file with all of our queries that we're going to ask it. And we'll take a look here. So here are all the queries that we're going to ask based on the given document. And next we set the file path for the results file. And essentially this will hold all of the outputs after we ask all of our queries. We also set the top K, and basically we'll be returning the top five most relevant chunks based on the given document. Next, we're going to initialize our clients. So we've initialized the OpenAI client with the OpenAI API key, as well as the Moorcheh client with our Moorcheh API key. Then we're going to load and chunk our documents. So we're going to chunk this document, and we're going to set the chunk size to 700 characters per chunk, as well as chunk overlapping 120 characters. And we set this to be the same for across all of the pipelines to ensure a fair and balanced experiment. But feel free to change these to whichever specifications you would like. Next, we have create Moorcheh namespace, and basically we set the namespace name, and we create the namespace with that name, and we set the type to text because we are uploading a text-based document. But you can also set it to a vector-based namespace if you want to upload vectors instead of text documents. Next is the actual uploading of chunks into Moorcheh, and here we'll be uploading the text as well as the metadata. And we also took the metadata considerations as well for all the other pipelines to ensure that it's a fair experiment. Next, we have the retrieval function which will retrieve all of the relevant context based on the top K. So we'll be retrieving the top 5 most relevant chunks that are uploaded to the namespace. And finally, we have the answer generation function, and this will generate the answer for each of the queries. And we kept the same prompt across all of the RAG pipelines, basically asking it for a relevance score and a completeness score from 0 to 100. And here we'll be using a ChatGPT to answer a query, but we also have an option for Gemini integration. And if you'd like to use Gemini instead of ChatGPT, all you have to do is uncomment all of these lines and also set your Google API key in your environment variables to use Gemini instead of ChatGPT. And also uncomment these lines and comment out the GPT integration. And finally, we have the actual main code that will run all of the functions and essentially write all of the output into a relevance.csv file, which is shown here. So here, if we take a look, we have the passage ID, the query, and the generated answer. And we also have basically the return passages, which are the chunks that Moorcheh has returned to answer the specific question. And we have one of these rows for each of the queries. And that basically concludes the Moorcheh demo. And all of these other pipelines also share a very similar structure. So feel free to sort of test the accuracy and benchmark of all the different vector databases as well.
So after getting the results.csv files from their respective vector databases, we'll also organize them in the spreadsheet as shown on our screen. So in each tab of this spreadsheet, we have a specific vector database for which we have a table as shown above. It has the query-generated answers and passages for both the GPT-generated results and the Gemini results for each query, so we can better understand which of the passages and why we get the generated answers as shown here. So if you scroll through the tabs, we also have a similar one for Pinecone, for Chroma, and for Qdrin, and as such for all the other vector databases. With this data, we compiled it into two separate tabs, one for ChatGPT, and in this tab, it basically shows the AI model, the relevance scores, the completeness scores, and the rationales provided by the LLMs. And we compiled this data by averaging it. We also have a similar tab for Gemini, in which we do the same thing. And you can see the results as shown over here. Taking the data together, we put this in a results tab in which we compiled all the scores. So here we decided to average the relevance and completeness scores for a more holistic view and understanding of the passage retrieved by the vector store. And as you can see in our graphs over here, Moorcheh performs the best across Gemini, ChatGPT, and them both combined. This is also aided by a visual in the Moorcheh AI website, where it has the combined performance shown as displayed here, and clearly Moorcheh outperforms all the other vector databases.
Well, to further understand the better nuances of our data, we've examined specific retrieved passages across vector stores to explain why Moorcheh's outputs were more relevant and insightful. And this report analysis is available in our discussion post in our same GitHub page, and this is the Moorcheh benchmark GitHub page. And here we provide a more detailed comparative analysis based on all of the other vector databases output and their passages and their generated answers. So our analysis demonstrates that Moorcheh performs exceptionally well on queries requiring deep reasoning and contextual understanding. Its responses remain closely aligned with the intent of the query, showcasing the effectiveness of its vectors representations and ranking algorithms in handling complex, high-context information. So we recommend Moorcheh as a reliable solution for semantic search and data management. Users can further optimize performance by customizing chunking strategies, query formats, and data inputs. For those interested in replicating or extending our work, we encourage you to visit our GitHub page, as shown here, where, as we mentioned, you can use our pre-built RAG pipelines, which are all available to evaluate semantic search accuracy. And so this study, alongside our discussion post, marks the first step towards creating a more rigorous and transparent framework for benchmarking vector databases. And so we'd like to thank you for your time and taking the time out of your day to listen to our video. And we hope to see you using Moorcheh in the future. Thank you.